For today's online lesson, we're going to learn a little bit about the perception of pain. According to the textbook, there are three components to the perception of pain. One is the basic sensory component, the perception of the intensity of the painful stimulus. The second component is the immediate emotional consequence of the pain, basically how unpleasant it is. And the third component is the long-term emotional implication of chronic pain. What is the threat to the person's future comfort and well-being? I like this particular approach to understanding pain because it highlights the emotional component, as opposed to just focusing on the physical aspect of pain. It's important to understand the brain and nervous system components that underlie the three aspects of the pain message. The sensory pain message is going to be transmitted via the spinal cord to the posterolateral thalamus and onto the primary as well as the secondary somatosensory cortex. The immediate emotional component is going to utilize all of those components we just talked about, as well as the insular cortex and the anterior cingulate cortex. And lastly, the long-term emotional component is going to add in the prefrontal cortex. That's the part of the brain that allows us to project ourselves into the future. So it makes sense that we would need a healthy prefrontal cortex to be able to worry about a long-term implication of a painful stimulus. Some interesting research highlighted in the text. One study is by Hofbauer, 2001. And this research has shown that hypnosis can alter either the intensity or the perceived unpleasantness of the painful stimulus. And when they did the research with the intensity, giving people suggestions that, oh, the pain isn't really all that intense, they saw a decrease in the activity of the somatosensory cortex. When they were given instructions that the pain they were experiencing wasn't nearly as unpleasant as they thought it was, then we saw a corresponding decrease in the anterior cingulate. So this is research that is going to support the different functions of the different parts of the brain in the pain perception process. Research by Osaka in 2004 found that the anterior cingulate can be activated simply by hearing pain-related words, such as headache. And this is again interesting because this highlights that this part of the brain doesn't have to have input from a direct stimulus that is potentially painful. It can be triggered by memories of pain or thoughts of potentially painful stimuli. Research by Singer et al. 2004 looked at couples. When women received a shock to the back of their hand, their somatosensory cortex lit up, not too surprising since they were experiencing a real painful stimulus. The thalamus, the insular cortex, and the anterior cingulate were also active. What was interesting was when the women watched their partners being shocked later, the same brain areas, except the somatosensory cortex, were active. And again, this makes sense. The somatosensory cortex requires a real input from an actual painful stimulus. The other parts of the brain are simply acting in that emotional aspect of brain. And in this case, what we're seeing is empathy. The woman can identify that the painful stimulus she is seeing being experienced by her partner is one that she recognizes as painful and unpleasant. So is pain all in your brain? Some people would argue yes, that the actual perception of pain is entirely a cortical process. That doesn't mean that there aren't damaging stimuli out there, because certainly, as you read in the textbook, there are folks out there who have a genetic disorder where they cannot perceive pain, but they certainly can experience some damaging stimuli. For most of us, we're trying to reduce pain or produce analgesia. And there's a lot of ways in which we can do that. The textbook highlights a number of these, and I'm just going to go through them quickly. Electrical brain stimulation can be used to stimulate brain areas directly that can trigger analgesia. The opiate drugs can also work in that way because they're going to block the release of substance P and block the pain message being sent from the spinal cord to the brain. Acupuncture also works well for many people. And acupuncture actually works through releasing endogenous opioids in our nervous system. It's not nearly as intense as if you were to take an opioid drug such as morphine, but we do find the same basic pattern of activation, just much less intense. Hypnosis can also work well. As we saw in the various studies, it can be used to block the intensity as well as the unpleasantness of the pain stimulus. The placebo effect also works very well for many people. And in addition, sexual stimulation. As you saw in the textbook, vaginal stimulation can block some of the pain perception. So it highlights the fact that our brain has many mechanisms for us to tolerate, attenuate, and modulate our pain response.